Hello and welcome to Chapter 3, Section 2, Logarithmic Functions and Their Graphs. Today we're going to look at logarithmic functions and the way they graph, and we'll notice that they are inverses of what we worked with previously, our exponential functions. So the first thing we're going to do is compare the graph of a log with the graph of an exponential function. So we're looking at f of x equals 4 to the x and g of x is equal to log base 4 of x. Now, to be able to get the numbers for my log, I know that y equals the log base a of x, which means that x is equal to a to the y. That's going from log to exponential form, because it is very easy for us to graph exponential. So we notice on our exponential graph, we put in -2, -1, 0, 1, and 2 for x. And that gives us 1/16, 1/4, 1, 4, and 16. Now, what we notice for our log is if we put in -2, -1, 0, 1, and 2 in for the y or g of x, we get 1/16, 1/4, 1, 4, and 16. Which is exactly the inverse of the previous function. And you can see from the graph that the blue graph is the exponential function and the red graph is the log graph. And they are inverses of each other, and they are inverses through y equals x. Next, we want to find the domain, the x-intercept, the vertical asymptote, then sketch the graph of each function. Again, the easy way to graph this is to change from log to exponential form. So we go ahead and do 4y to the x plus 3. Well, of course we need it set equal to 0, so we subtract 3 from both sides. So looking at our graph, after we graph it, we know that our domain is from -3 to infinity. And the x-intercept is at 2, -2, 0. And our vertical asymptote is where x equals -3. Now, where would we get this -3 from? I believe if we look back at our equation, we'll see where we get the -3 from. Okay, in this one we're doing f of x is equal to log base 4 of -x. Well, again, we're going to change from log to exponential form so we can easily find the points, and that gives me 4 to the y equals -x, or -1 times 4 to the y equals x. Okay, that negative, what does it do? Well, it flips it over the y-axis because it was with the negative, it was with the x. So that flips it over the y-axis. That means our domain then is going to be from -infinity to 0. Okay, and the x-intercept is going to be -1, 0. And our vertical asymptote, well, we can see there is nothing being added to the x, so our vertical asymptote is going to be x equals 0. Okay. Now we want to use the one-to-one property to solve the equation for x. You make the base of the exponent the base of the log, and the log becomes the exponent. Okay, we've got log base 5 of y equals log base 5 of 16. So that means the base of my exponent is going to be 5, and I raise the logs to the exponential. Since the base and the exponent and the base of the log are the same, they cancel each other out. So that gives me y equals 16. Okay, in this one, we don't see a log being written. If a base is not written, it is understood to be 10. So that means I'm going to use 10 as the base of my exponential, And that just crosses out with the log, so that gives me 4x minus 3 equals x plus 2. And then I just solve the equation. I'm going to subtract x from both sides, and I'm going to add 3 to both sides. That gives me 3x equals 5. Divide both sides by 3, and x equals 5/3. We're going to do one more example. We see that the base of my log is base 3, so the base of my exponential is going to be 3. And when I do that, the exponential and the log cancel out, leaving me with x squared plus 4 equals 29. Since there are no other x's involved except for the x squared, we can just go ahead and just subtract 4 from both sides and get x squared equals 25. Now we know, of course, to get rid of the square root, I take the square root of both sides, and x equals, and now don't forget, anytime I take a square root, it has a positive and a negative root. So I have a plus or minus 5. Okay, that should do it for section 3.2. I hope you enjoyed the video.